Welcome to today's demonstration titled 6 Main Use Cases for Nlyte Energy Optimizer. Before I turn it over to Bob to go through the 6 specific use cases and go through a demonstration, I just wanted to show where Nlyte Energy Optimizer fits within the Nlyte solution suite. Nlyte has 2 main solution suites, which is our Data Center Infrastructure Management Suite and our Technology Asset Management Suite. And under both of these, we have Nlyte Machine Learning. Today we're going to be focusing on Nlyte Energy Optimizer, which is part of the Data Center Infrastructure Management Suite. So I'm going to turn it over to Bob. Bob, why don't you go ahead and introduce yourself?
Hello, my name is Bob Parker. I'm a Senior Solutions Engineer with Nlyte Software, and I've been asked to show use cases of our Nlyte Energy Optimizer application to either existing customers of our Asset Optimizer application or prospects that are interested in looking at the two. So I've come up with 6 use cases that I'd like to cover, and we'll take a look at those right now. So the first is energy capacity planning with real-time trending. We'll cover what it looks like in the Asset Optimizer when you add the real-time energy monitoring of Nlyte Energy Optimizer to really complete the package of a full DCIM suite application. Secondly, we'll be able to show within Energy Optimizer unused or underutilized infrastructure. We'll then move into a discussion about raising data center temperatures safely, being able to raise the set points of your crack units and to very accurately monitor the ambient temperature in the racks to determine if it's getting too hot or not. So you can safely move the temperatures up and monitor that through Energy Optimizer. And then we'll move on to alarming and alarm workflow. We'll briefly show some alarming at the beginning, and then we'll look at how the alarming application within Energy Optimizer can coincide and integrate with the workflow within Asset Optimizer to be able to actually generate a workflow when an alarm has been detected. We'll briefly talk about co-location monitoring and how Energy Optimizer can be used to monitor power in your colo environments to determine whether or not you're being overcharged, possibly, or being charged correctly for the power that you're using, as well as temperature, right? Being able to monitor the temperatures in your suites or in your cages to determine if your provider is staying within the SLAs that you may have with them. And then finally, with Energy Optimizer, we'll finish up with power failure simulation, how you can actually look at your power chain and selectively fail different pieces of equipment to see what would happen if the A side would fail over to the B side and so on. Again, a very good way to look at the redundancy within your power network. So let's get started. We'll begin with energy capacity planning and real-time trending. So when we jump over to Asset Optimizer, we're going to start here. There's a few things that I want to show you how the application is really enhanced by the use of Energy Optimizer. The first thing that you'll see is alarms that are coming across from Energy Optimizer. Again, we are now an Asset Optimizer, right? This is the planning tool. This is the asset rack elevation application that most of you are familiar with. But when you add Energy Optimizer that's integrated internally with the Asset Optimizer piece, you can see there's a whole wealth of knowledge that's added to the Asset Optimizer application, completing the circle, if you will, for DCIM applications in general. So a couple things. Obviously, you can see the alarms that are generated. And when we jump over to Energy Optimizer, you'll see that these are the same alarms that you're seeing in the Asset Optimizer screen right now. But where I want to focus your attention next is on what we call the heat/energy or power gauge over here. Now, those of you that are familiar with Asset Optimizer know that this gauge represents the amount of planned power that you have in your data center. So the top line obviously is the absolute max of what this room is designed to handle. In this case, it's 1.5 megawatts. And then we allow you, as you're familiar, right, to set different heat limits or heat thresholds where you want to manage your power to, right? Power/heat, basically the same thing. So these are buffers, right, between here and here that you can safely add power and manage your power with the effective cooling that you have within the data center. Obviously, the blue line here is all of the equipment that you have within the data center inside the racks, and that's the estimated power based on the derated value of the nameplates. So that comes from our materials library. Now, when you add Energy Optimizer to the mix, you also bring in now real-time power. So you can see now that the real-time power that we're pulling either from branch circuit monitoring, from in-rack power strips, or from busway brings this information in here to the heat gauge. So now you have a very complete use case in terms of being able to not only plan for your power, but see how you're doing in terms of the real-time power. So real-time power also, as well as real-time temperature, come through the application in a couple different ways, right? So this is the main area, but as you go to different areas, if you zone off different areas within Asset Optimizer, you can see that you have these statistics and the same thing occurs, right? You have the real-time power being added to the different thresholds and estimated power that you see, as well as going down to the actual rack. So if you click on the rack itself, and again, those of you who use Asset Optimizer know that this exists. But now when you package Energy Optimizer integrated with Asset Optimizer, you also get the real-time power that's being collected from the either the power strips or from branch circuit monitoring or busway. All right, more on that in a second. Going back to the data hall, I did want to show you some other areas where real-time information is captured within the application from Energy Optimizer. You may be familiar with the overlays, right? The overlays show you different color coding for different types of quantities, right? So we have cabinet use space, cabinet ports that are free, but you'll notice that in the stack here, we have real-time power KW, and we also have real-time temperature. So if we take a look at real-time power and we apply this overlay, you'll see that that real-time power does come across. And if you remember from Energy Optimizer, this area, we had some alarms that were going off, and you can still see them, kind of an overloading condition, right, in this area, greater than 9 kW. All right. We also have the ability to look at real-time temperature. So if I come back here and look at the overlay for real-time temperature, and apply this, you'll see that the real-time temperatures that are coming from NEO or Energy Optimizer are also brought across into the overlays. All right, and we'll see a temperature map in just a few minutes when we get into Energy Optimizer. The last area that I want to show you is, while I'm still in Asset Optimizer, is real-time power. Right, you've seen it now kind of quantified in terms of overlays and also in the graphs, but I want to show you real-time numbers that come across through the integration of the two applications. So let's take a look at cabinet Dallas 001, and you'll notice that when this comes up, this will be a picture of the cabinet itself, and we'll be able to take a look at some real-time power statistics. So if we look at real-time data for the cabinet, and we'll take a look at the graphic itself, right? We took a look at this before, but if you look at the cabinet and we look at the link that we have here open in NEO or NSUM, this will take us directly to the link that we have in Energy Optimizer. And this will open up the cabinet, and you'll be able to compare the actual power that we're collecting in Energy Optimizer and see that it's captured in Asset Optimizer as well. So here we have the cabinet load, the strip load of 4.3 kW. If we jump back to the view that we had earlier in the gauge down here at the bottom, you'll notice that the purple line, again, is at 4.3 with a little bit of a rounding error, but you can see where that data is coming across. In addition, we can also look at the actual devices. So here is power strip B, I believe, for Dallas 001. Right? And if we look at the asset itself, and we again look at real-time data, you'll notice that we happen to be bringing across the real-time power in kW from that entire power strip at 3.0, almost 3.1 kW. Again, if we look at the deep linking within the application, we can open this device in Energy Optimizer and be able to see the same information captured at the device level within Energy Optimizer. So this will bring up the actual power strip, and you'll see here's the the KW that we were just looking at within Asset Optimizer coming from Energy Optimizer. All right, so that shows the deep linking within the two applications and the rich information that we get now of planning data within Asset Optimizer, now coupled with real-time data coming from Energy Optimizer. Now we're going to begin a transition from Asset Optimizer to Energy Optimizer and show you the values of the application and dig a little bit more deeper than what you've seen already. So as we move into Energy Optimizer, you'll notice that there are dashboards and reports available in the Energy Optimizer application as well. The first one that we'll take a look at is the summary portfolio. And this is where we capture rolled up information. So just like with Asset Optimizer, you can have multiple locations, multiple facilities, multiple rooms, and those also show up here in Energy Optimizer. So in this case, we have about 7 data centers or 7 locations that each have different data centers, different floors. On the right-hand side, on the first tab, we show the efficiency. So if you're able to monitor your entire facility load and be able to separate out IT load, we can give you real-time PUE and the inverse of that, which is data center infrastructure efficiency. We show you total energy consumption for all of your locations, as well as our capacity charts, which we'll spend some more time in. Now, again, this is all rolled up. So this is the summary portfolio. So this is for all of my locations, all of my sites combined. Now, you can drill down into different locations, facilities that will have their own dashboard as well. But before we get there, you'll see that in the capacity section, we capture used quantity versus real-time capacity, or what's available. So by using the Starburst graphics, this really gives you, without going any further into the application, the ability to see what power has been utilized or what's being consumed versus what's still available. Okay. Again, in the Asset Optimizer piece, that's all planning, right? Everything in terms of planning, what your size of the rooms are, what your planned energy consumption is going to be. And then when the added of Neo, you can see the real time. But here, what you're looking at, these capacity graphics in the dashboards of Neo allow you to look at what's used totally in all locations. And then as you branch out to a different facility, a different floor, and a different room, you can see what those totals are in terms of what power is being consumed, and also on the other side of what's available, right? So you really have a quick look now to see planning information of what's there and what's being utilized or what's being consumed. So we have that for power, cooling, and space as well. Now from here, we'll navigate down to the actual data center room and take a look at how we get the energy monitoring from the different devices, whether they be power strips, in-rack PDUs, power strips, branch circuit monitoring, or busway. So as we navigate to the room, now this is the same room that we saw in Asset Optimizer, and you see that the alarms are active as well. Again, these are the same alarms that you saw back in the Asset Optimizer application. But here, we are able now to monitor PDUs. As you can see here in the corridor outside of the main data center hall, we have the A side PDUs, the B side PDUs, and then we also have RPPs that are supporting the circuits that are going to, in this case, in this area, we have cabinets that are supported by in-rack power strips. In this area, we're showing cabinets that are supported by branch circuit monitoring, and this is busway. So those are the 3 main ways that we're able to get down to actual circuit power distribution into the data center. So by drilling down on a cabinet, you're able to see, again, the power that's being consumed by, in this case, the individual power strips. You saw some of this earlier when I did the example or showed the example of the in-rack power strip. But here you get to see the actual power strips themselves. This is power strip A in that cabinet, and this is power strip B. And again, this is the one that we looked at earlier. So you're able to see what the total KW is versus amperage in terms of 3-phase power. So this is a 3-phase power strip. We can break that out and alarm on any of these phases or phase imbalance or total power strip value if that's something that you're interested in. So this is power strip A and B. But up here we have the cabinet history in both wattage and amperage. And again, this is the information in terms of wattage that is passed over to the Asset Optimizer application that I showed you earlier. All right, so that's a look at what in-rack power strips would look like within the application. Moving on, if you have power distribution to your circuits through your branch circuit monitoring, this is what that will look like. The top part will be very similar to showing you the trending of the cabinet, But at the bottom of this display will be the looking at the individual circuits and seeing what they look like. So in this case, again, down here at the bottom, we have two three-phase circuits that are coming into this particular branch device. You can see A side, B side, and we're teaming those together to get an A side, B side total load, right? And then up here, we also have the information for the cabinets in wattage and amperage as well. And then finally, the third way that we monitor power distribution to the rack is through busway. So if we take a look at the end feed, and we're able to show tap-offs as well, right? We can take a look at not only the end feed for the busway, but also the individual taps that are going to the individual cabinets. Again, they're monitored very similar to the in-rack power strips, but they are capturing power at the tap-off that's being distributed to the servers that are inside of the rack. So again, three ways to look at the power distribution in the application: branch circuit monitoring, in-rack power strips, and then as soon as this loads, we'll take a look at the ability to see the in-rack, the busway. Okay, the busway has loaded, and here is the end feeds that we were talking about, and then each tap, right? This is the A side, this is the B side, showing the individual taps. You'll see we do have an alarm on phase B on one of the taps that we can drill into and take a look at a little bit later. But again, that's an alarm that's currently active because we set a threshold of maybe 12 amps or 11 amps, and we've gone above that, and that's generating the alarm. So a little bit more on alarms later. But if we navigate back to the room, you can see the alarm that's active right here, and this is the one that has the phase B that was overloaded. We also have an alarm that's considered a teaming alarm, looking at the A side and B side at the total combined, and being able to show you a warning alarm that will say, hey, if A side or B side drops out, the remaining circuit may not be able to handle the load. So if we drill down onto this cabinet, the team alarm is now showing you that the A side, B side combination is higher than what one circuit could handle. So in this case, we have three-phase circuits. We have an A side and a B side, and it looks like phase C at 11.6 of this circuit. When you add those together, that's 23.2 amps. That's already higher than what one circuit could handle. In this case, these are 20 amp circuits. So if we lose one of the circuits, the remaining circuit may not be able to handle that failover load, which would create a critical condition. So the team alarm is a proactive alarm that lets you be kind of proactive in terms of looking at your infrastructure to be aware of something that may be an issue later on. One of the other great benefits of Neo is to be able to not only monitor the white space and look at cabinet power distribution, which we've been looking at, but you can also monitor facility gear as well, UPSs, crack units, things of that nature that are affected that support the data center. So in this case, we're going to take a look at two items, the equipment yard and the main power room, and you can see how we monitor that facility information. So in the equipment yard, which I have open here, you can see that in this case, we're monitoring a few different items, right? Number one, we're monitoring the generators, right? This is one generator here. The utility is here, utility A, and then also down here is utility B, as well as fuel storage for the generator. So basically any meter that you have that's on the network, we can monitor it as long as it's on the network, number one. And number two, it gives out information that we can collect over our standard protocols such as Modbus, BACnet, SNMP, Modbus TCP, OPC, XML, JSON, and a few others. So those are the main protocols that we see to be able to monitor the different types of devices that you may have in your data center, in this case, in your facility. So again, generators, utilities, fuel storage, water storage tanks, water pumps, condensers that are outside or on the roof. Again, if they're on the network through your building management system, we can pull data out of that, or we can go directly to those devices if you have those hardwired to a network. In addition, let's jump to the main power room where you can see where we're monitoring. In this case, we have the chillers here. We have some chilled water pumps that are being monitored, as well as the UPSA, right? If we hover over this, you'll see the UPSA pop up in a quick look and see the UPS information real quickly. We could drill down a little bit further, but you can see some of the basic information that we're monitoring here. And then we also have UPS-B over here. And then we have the UPS panels, meters, and then we also have the power line switchgear that is here between the generator system and the UPS. So again, any facilities gear that you have in your environment that is either on the network through a building management system or a building automation system, or if they're directly wired to your network through serial connections, we can monitor that information and bring that data back into Energy Optimizer. So one of the advantages of having the real-time power available is now you make this information available to more people. Most companies, organizations don't let people into their building automation systems or building management systems just because there's the effect of possibly turning something on or off. With NEO or Energy Optimizer, you're monitoring only, right? So you're able to take a look at this information and make that data more available to more people without exposing the risk of having others into your building automation system. So from there, we'll move to the second use case, which is identifying unused or underutilized infrastructure. All right, so this is use case number 2. And we'll take a look at how NEO or Energy Optimizer can help us find unused or underutilized infrastructure. To show this, we'll navigate back to Energy Optimizer and we'll take a look at the data center floor. And one of the items, as I mentioned earlier, is that you can track circuits and panels, and you can take a look at the devices that are out there and how much power is being consumed. So before we get to the circuits, I did want to point out that if you notice in each of the cabinets, there's a blue square or blue fill represented inside of the cabinet. So you can see they vary in size. And what that's doing is representing the amount of load or power being consumed in those cabinets in kW versus the rating of the cabinet. So this is a way to quickly identify where you may have additional capacity, or sometimes called stranded capacity, of power where you could actually put in more equipment, right? So if I look at this row right here, for instance, the specs or the blue fills are not that big, but compared to what we see here in the area of the busway, you can see the difference. So this is one way to quickly identify where I have additional capacity that's not being used. In addition to that, we can drill down onto the individual panels. So I've highlighted a panel here, RPP panel A1, and as you can see, we have load on all of these different circuits, but look at all the empty circuits that we have in this particular pair of panels, right? This is panel A, and this is panel B. So these are teamed panels, but you can see we have a lot of empty circuits that are available in terms of capacity. So I could run a report, I could look at this graphically and kind of bounce between rooms to see where I have additional circuits that are available. We currently have a lot of power coming to these PDUs. They're being supported, but in this case, these circuits are underutilized. So we have more capacity that we could tap into through this capability by looking for unused capacity or stranded power, as we like to call it. The other way to identify stranded capacity or unused power is to look at our power view power failure simulation, which we'll cover in just a few minutes. But here you have your real-time power chain starting from your utilities, coming through the utilities to the transfer, static switches, UPS, and so on, where you can hover over these different areas to see what the current loading is. So looking at it in kind of a one-line diagram, if you will, being able to see where you have power, and you could open up different areas or different devices to be able to see what those power loads are and to be able to identify stranded power or unused capacity that way. We also have the ability to look at it at the summary, right? We showed you this earlier where you have the capacity chart showing power. Now this happens to be for the room. I showed you the summary portfolio for everywhere, but again, using your mouse, being able to see what's used versus what's available is a third way to be able to identify unused or underutilized equipment or capacity in your data centers. We're going to take a look at our third use case, which is raising data center temperatures safely. Now, 10 years ago, I think you would agree that we could walk into a data center and need a coat, because the way to make sure that we were keeping the servers cool enough was to just blast cold air from our crack units and not really worry about the amount of power that's being utilized to overcool the data center. Well, now with tools such as NEO, Nlyte Energy Optimizer, we're able to safely raise data center temperatures by slowly raising the temperature of our crack set points and seeing the effect real time of what's happening out on the racks. So if we take a look at NEO again, one of the things we can do is look at a heat map, which will give us the location and the current temperatures of the data center, in this case, in the cold aisle and in the hot aisle. These green T's represent the locations of in this case, wireless temperature sensors that have been placed on the data center floor. So if we go to our heat map, you'll be able to identify hot spots or cold spots within the data center. As I blow the image up, you can see the current temperatures and the color coding that represents the ambient temperatures in those areas. So you would expect, obviously, the cold aisles to be somewhat blue, hot aisles to be more on the yellow, the warm side, and in this case, red, and the outer areas over here where we have the containment for cooling, right? We have a cold aisle containment set up over here. You can see the hot air is out in the back areas of the racks. One of the things that you can do with the heat map is go back in time to be able to look at trending of temperatures. So we're looking at, in this case, daily information, but you can, in terms of playback, you can look at 1 minute intervals, 15-hour, daily, weekly, or monthly intervals to get an idea of what temperature trending has taken place. So in our example, our use case of raising the temperature in the data center by slowly raising the crack set points, you can raise it maybe 2 degrees a week or be more aggressive, if you will, and raise it sooner than that. But you want to see what the effects are going to be, right? So by being able to go back in time, we'll leave it on a daily. And the other thing you can do is look at different elevations. So you can study just the temperature sensors that are at the top of the rack, the middle, the bottom, in the ceiling, or under the floor, to be able to get a reading, again, depending on what your study is looking at. So we can go back in time. We'll go back to the beginning of September, in this case, and we'll play this forward, and you'll be able to see how those temperatures change over a period of time. So as I click the button here, we'll actually move forward, and you can see now that the temperatures are showing us, in this case, the average temperature each day for each of the temperature sensors. All right, so this is a great way to safely raise the data center temperatures at the set points, at the crack units, and then overall reduce the amount of power being consumed to power the crack units, to power the chillers, and reduce your energy spend, giving you a better PUE and being able to be more efficient with the power that you are consuming in the data center, in this case, reducing the amount of power going to cooling. And NEO gives the ability to do that safely. The fourth use case that we'll take a look at is alarming and alarm workflow. So you've seen some of this earlier when we were making our way through Nlyte Energy Optimizer in the area of alarming, right? In this case, we have 3 alarms that are critical in the Dallas data hall. And I showed you some of those alarms earlier, looking at branch circuit monitoring, busway, where we've reached a critical level on that particular circuit, or in the case of the teaming alarm, where the 2 circuits, the A side and the B side, are at a load that one circuit could not handle. So all those alarms bubble up into an alarm area that you can see these alarms and analyze them. But the one area that I want to talk about is pairing Asset Optimizer's workflow with the integration into Energy Optimizer's alarms. So with the tight integration between the 2 applications, again, rounding out that full suite package, you're able now to detect an alarm, and through the use of workflow with an Asset Optimizer, create a workflow. So an alarm can be generated in NEO and then spawn a workflow where it might be, step 1, do this, step 2, do that, to identify what that workflow is, to have a set procedure to be able to handle alarms as they occur. So in order to demonstrate this, we have a room, an office room that shows desks and chairs, conference rooms, but we also have down in this area, we have a couple of racks kind of in a closet. We also have a temperature sensor where we're monitoring the temperature in this area. So what we're going to do is simulate an alarm by activating, going in directly and increasing the temperature on this particular temperature sensor. So to do that, I'm running this on a virtual machine on my laptop. So I'm using ModSim. I'm going to come in here and just change the temperature from 75 to 87 and update that. And then in a few seconds, this should generate an alarm inside of NEO for the office for that particular temperature sensor. and then we'll go ahead and see how that spawns an alarm, spawns a workflow within Asset Optimizer to be able to show and kick off a procedure of events to take place for that alarm. In this case, it's very simple. It just shows the alarm in Asset Optimizer and then shows you when it was generated, when it was acknowledged, when it was returned to normal. But obviously, there could be a series of events that your technical folks or the folks in your command center would follow to help mitigate this alarm. So let's go back to Energy Optimizer and we'll refresh the view here, and we'll see if we have an alarm. So going back to the office, you'll see we indeed do have an alarm. All right, and now I set it at 87 degrees, so that was above a threshold that we set for that particular temperature sensor, and we are in alarm. You'll notice that the critical alarms went to 2 in this facility. Now, if we navigate back over to Asset Optimizer and we take a look at our workflow, and we'll take a look at the group's active requests, this should kick off a workflow that is the steps in order to take a look at the alarm. So we'll take a look at this and see what we have. Okay, the workflow has shown up for the office temperature alarm that has been activated. Again, this was the generation of the alarm from NEO, and workflow now has captured this particular incident and is kicking off a workflow for that. So a couple things, right? You can see that the alarms has increased. So if we take a look at the alarm count, and again, this is an Asset Optimizer now, you'll see that this is the alarm panel that comes from NEO, right? And it shows that we have a critical NEO workflow alarm, which was the office area. So going back to the workflow, if we open that up, you'll be able to see the actual alarm, the office temperature unit. It was in a critical alarm. You have the active date and time, and then you have the Nlyte or the Asset Optimizer active date and time where it came in. Now, what we'll do is we will acknowledge the alarm, and we can do that right here in the alarm summary area, either in Asset Optimizer or in Energy Optimizer, by coming in here, and we'll look at this this alarm, and we will acknowledge it. Make this a little bit bigger. Actually, I'm going to do it in NEO. It's a little bit easier there to see the alarm package. So we'll bring up the alarms here, and we can stretch it out. And again, this is that critical workflow alarm. So we'll acknowledge it and submit that. And what this will do is it will allow in the workflow a timestamp for when the alarm was acknowledged. So if you're following procedure, you need to look at when the alarm was generated, when it was acknowledged, and then we'll look at return to normal. But again, depending on the time frame that it took between the alarm being activated and the alarm being acknowledged, might allow a workflow to go to a second level, right? So maybe there was no one in the command center, and then might rotate to a manager or a security guard or something of that nature. Again, these workflows can be designed however you want. Again, for those of you familiar with workflow, know how they can be built out and be very specific as far as what tasks need to be completed. All right, so let's take a look now that we've acknowledged the alarm. We'll go back to the workflow, and we'll go back into the workflow item, and we should have a a acknowledged date in here now. And here's the acknowledged date and time. All right, a little bit later than it was activated, obviously. We'll then return the temperature back to normal. So if we go back to our virtual machine and our Modbus simulator, we'll return this now. We'll put it back to 75 degrees. We'll update that. All right. Now what this will do is reduce that alarm or return the alarm to normal because the temperature went back down again. So we actually created a spike. So we'll jump back now over to Energy Optimizer, and we'll refresh this. And you can see the alarm now is green, or the temperature status of the temperature sensor is green, which means the alarm has returned to normal. And you'll notice that the alarms have dropped out. And if we go back over to Asset Optimizer, and we'll refresh this, we'll go back to the alarm summary and go back to workflow. And you'll notice that the active requests have dropped out, so that has closed. And if we look at the actual workflow itself, you'll notice that we have a return to normal. Right here at the bottom. Date stamp when that alarm was returned to normal. So this workflow has been completed. Again, just as a recap, adding alarming into the mix with Asset Optimizer's workflow. When alarms are generated, they can kick off a workflow within Asset Optimizer, go through a procedure, process, steps of handling that alarm, whether it be identifying people, make calls. In this case, very simple example of just showing you the active time, the acknowledged time, and the return to normal time. The fifth use case that I'd like to cover is co-location monitoring. Often when we're talking with prospects or even existing customers that are running Asset Optimizer, they'll say, well, I don't need Energy Optimizer because I have my data center in a co-location facility, and that's really on them to determine the power being utilized in my suite or my cage. However, I would argue that you probably would want to trust and verify the billing that you're getting. So Neo allows you to monitor sites, including a site that you may have in a co-location facility. So co-location monitoring is important. Now, obviously, we have co-location providers that are using Neo, but we also have tenants or customers that are tenants of co-location providers, where they may have their own data centers, but also have some data centers in co-location facilities, and they're able to monitor that. So let's take a look at Neo, and we can see where that is taking place. So again, a very strong use case. So in this case, we have my data center, right, the Dallas data center, but we also have a co-location hall that I might have in a different location. And in this case, this is the co-location hall, but I only have access to the open areas here. So this may be where my cage is, right? There's other areas that the provider is probably not going to give me access to in these other areas, but I do have the ability in my own location, right, to just not even show these or not show them. It's up to me, but I can have my colo environment right here where I can take a look, and if I have in-rack power strips, that's probably the best way if you have a colo environment to be able to see your power draw is through in-rack power strips, because it's unlikely that the provider would give you access to their PDUs or their branch circuit monitoring. So you can have a colo environment within Neo and be able to monitor that and be able to challenge not only your power consumption, but also your temperature. I mentioned that earlier, where you can verify and check and make sure that your provider not only is billing you correctly for your power, but also the temperature in your area, your suite, or your cage is within possibly an SLA requirement that you have with the customer. I'm sorry, with the provider. And then the final area that we'd like to cover, and the final use case, is power failure simulation. Now, we looked at power failure simulation a little bit earlier when I was showing you the ability to identify stranded power and how you can look at your power chain and determine where you might have stranded power by looking at the real-time values on those devices. But PowerView was primarily designed to be able to look at what happens if I were to lose the A side or the B side at different areas of my power chain or different levels, starting at the utilities here at the top, working through the ATS switches, static switches, UPS, and then down to the PDUs. So as I showed you earlier, you're able to hover over any of these devices to get your whatever points or whatever functions you determined you wanted to see. In this case, three-phase power and KW are all available. And what you can do now is simulate what would happen if I were to lose a PDU. Now, we talked earlier about teaming, and that's where I was showing you the alarm where we had two circuits going to a cabinet, and the combined load of those circuits was higher than what one circuit could handle. So the PowerView simulation tool that you're looking at now was an add-on to that, or a kind of a deeper dive into that teaming concept. So in this case, we've paired PDUs together. They have teams, right? PDU A1 has a team, which I believe is PDU B1. And you can see that here if I bring up the device details, you can again see what the power loading is. And then you can also look at different areas here in terms of different PDUs and what's being utilized on those areas that we showed you earlier. But in this case, PDU A2 does have a backup, which is PDU B2. And we'll take a look at what happens. So what we're going to do is simulate a power failure, and I'm going to turn on multiple so we can see the change at the same time. So PDU A2, let's say we want to see what would happen if PDU A2 were to have a failure. So I can simulate this by clicking on the power button. And what will happen, obviously, this PDU will drop out because I, in effect, virtually turned it off. But you'll notice that PDU B2 also failed. And this is an indicative of a cascading failure of the primary PDU failing, and you can see the secondary PDU failing as well because it didn't have enough capability or enough power to be able to handle not only what it had, but the failover from the A side. Now, in terms of a legend, you can see what some of these symbols mean. So the red down arrow indicates a failed device, which is obvious because I went ahead and virtually failed it by clicking the power button. Now, if you look across on the B side, you'll see that we have power loss in the panel, which is downstream of the PDU, obviously. There's a purple line with an up arrow in it, which indicates a device failure due to a cascading effect. All right, so that's the failover because it couldn't handle that, so it was a cascading failure. But then the green arrows all the way up the power chain here, and then as we work up through, show power loss. So you can see the green indication here. The green down arrow indicates a device with lost load upon simulating the device. All right, so that shows you that there was a power load. Now, PowerView gives the ability to run these simulations over and over again by resetting the devices and then possibly refailing at different locations to see where you might have an area that's weaker than others, right? And determine where I might have vulnerability in losing an A side, B side failover scenario. So PowerView not only shows you power loss, but it also can be a preventative measure if you have to take down a PDU or a UPS for maintenance and you want to see what's affected. You can see downstream or what failure might occur if I were to take that down. And obviously prevent you from having a mishap, if you will, based on friendly fire or taking down a device for maintenance. So PowerView will give you that power failure simulation based on real-time data again, right? This is simulated, but it's based on real-time loading at those different device levels, starting from the utilities down through the switches and down actually to the PDUs and the panels. So that wraps up our last use case for Energy Optimizer. Again, as a recap, pairing Energy Optimizer with Asset Optimizer gives you a complete package of being able to look at DCM not only from planning, from asset management, rack elevations, and connectivity, which you get in Asset Optimizer, but the power that's brought to that with Energy Optimizer of the real-time data being used to affect not only alarming, but capacity, and then as you saw with being able to simulate power failure with NEO. So hopefully this was helpful. And again, thank you for your time.
Thanks, Bob, for that demonstration. If you'd like more information about Nlyte Energy Optimizer, NEO, please feel free to visit the website at nlyte.com/resources. We have information, data sheets, white papers, case studies, and videos specifically on Nlyte Energy Optimizer. Thanks for attending.